In this video, I will try to build my own tokenizer from scratch to train my LLM, small LLM, and I will do many tries. This is more like a vlog where I will just tell you, document what I'm doing and the mistakes and the problems and how I'm solving them. And I removed all of the boring parts in between. I'm just saying what's happening, and stuff. It's everything is cut. And we will learn a lot. So if you want to build tokenizer from scratch, you will learn about problems you will encounter and my solutions. And in the end, we will just use DeepSeek R1 tokenizer because it's too difficult to build one from scratch. And R1 and these tokenizers are really good as well. But anyways, you will learn a lot about tokenizers, and I will be able to build a tokenizer as well. But it will just be worse than DeepSeek R1 tokenizer, so we will just use that in the end, but you will learn and you can build your own as well. So if I run this should automatically connect to T4. Yeah, and then it should generate. It should download everything and generate. So let's see what happens. It should generate my token of 120 something thousand. GPU memory, whatever, large scale Byte-Pair Encoding tokenizer. What? Wait. What is 2 to the power of 17? Should be this number, yeah, 131,072, yeah. Okay. 12 billion characters. Minimum frequency fallback. So a token needs to appear 2000 times in this training data, or at least 1000 times, because less than that and it will not be learned properly by LLM. So this will take several minutes. It will take more than several minutes, but okay, I'll just let it be. Maybe it will take like 10, 20, 30 minutes to fetch 12 billion characters. And I hope my RAM doesn't go bust. I think it will not. But how much is this? So million would be megabytes. So 12,000 billion would be 12 gigabytes. And I have 15 gigabytes. Oh, it will be rough. I don't know if I will also generate more data based on that, so it is what it is. Let's see. Looks like this is gonna take 4 to 10 hours to do. So I guess maybe, but it's just 12 gigabytes or something. So I guess I will download it to my MacBook and then I will generate the tokens on the MacBook. Maybe it will be faster. So we'll see. I'll ask Claude AI to create a Python script for me. So I did generate the code. I'm looking at this, how fast it's downloading. What's happening? It's 3%. It's still 3%. No, it's not this one. So it's downloading quite slow. Actually, 1 hour. That's not even too bad. 2 hours. If it's like 1 hour, we'll see. It's not maybe too slow even. 2 hours. So let me run this download script immediately. There is no modules. Also, this already downloaded almost 1 billion. So just like 1.5 hours. Okay, now let me copy. Oh, but my system RAM is so high. I guess let me copy this and install this into my cursor thingy, my environment. And the second set. Okay, so fast. Now let's try running. It doesn't have my Hugging Face tokens, so I don't know if it's gonna ask me for it or something. Now we are just waiting, I guess, to see what happens. I'm downloading it here and also here, so I guess one will work. So it crashed on Google Colab after using all available RAM. So I will just try the strategy of downloading it to my MacBook instead. So even my MacBook one failed, so I'll try a different way. I go to the dataset and files and versions and right click here. I go, so whatever, I go here, data, file, so files and versions, data. Let me choose the latest one. This is 2024. I go here, right click, copy link address, back to this, and I said just download this, fetch this data, and it did. I don't know what this block size is. Anyways, I will tell it now concat all text fields and write total length. So I will accept and run. We have a lot of characters. This is 300 million characters. So if I want 12 billion, that will not be even too much actually. I think I need 3 times this is 1 billion times 12, 36 of these URLs. So they actually have number in name here, train, and then 0001. So let me copy link address. So we will go and let me see if there is any pattern here. It looks like there is. Looks like it's same. It's just here. The difference is here. Okay. Then I will tell this guy. So I need you to fetch data from URLs same as this, just change this part to all the way to this part, go one by one. So 36 in total. Make sure to release system memory, save it on disk, the characters as you download and concatenate. Don't have them all in memory. Okay. Guys, this is AGI. This is AGI. I repeat, this is AGI. Let's run step by step. I don't want it to start running everything. Here we got the first one. Accept and run. So append each constructed URL to the list. So this is the list of URLs. If I click any of them, cancel. So you see it's downloading. Nice, it means it's good. Okay. So then it's gonna start downloading, raise an exception bar, status, whatever. Okay, accept and run. You see it's downloading pretty quickly. Downloading complete. I wonder how many it will download, because I told it not to keep everything in memory. Okay, I guess, but this is downloading so fast, and each of these is 300 million characters, I believe. I don't know if it's gonna stop, it's gonna just crash. Because each character is 2 bytes, I guess. So 12 billion characters is 24 billion bytes, which is 24 gigabytes. But we only have 12 gigabytes, which is gonna be an issue. I wonder if it's being saved. It looks like it is. Ah, okay. Maybe it's not being loaded into RAM. Yeah, it's just being downloaded here. This is very good. It already downloaded all of them, which is so much faster than the dataset workflow we had. This took like 5 to 10 minutes. So now it wants to load the text. The problem is it will crash. Cancel. You cannot load all at once. I said you have 8 gigabytes of RAM, which it has more, but some is used already. And each file has 300 megabytes, so you need to find a way to concatenate text to extract and concatenate text without loading them into RAM. So let's go. So now it will do these subtasks and stuff. I'll just trust it. I think it's not that stupid. Why is it generating URLs again? Okay, loop through the URLs, download. What? You already downloaded. You already have the files downloaded. Let's see what it's gonna do. Okay, now it's gonna start loading and manage the memory process. Accept and run. Let's see what happens. Processing the first one. Okay, we got some text stuff in here. Appended text from 0000. Total characters so far 300 million. And then processing 2, okay. Appended 2 as well. Now we have 650 million characters. Okay. And then we got 960 million characters. My system RAM is spiking, but I guess it's getting freed as well after this is finished. I think it's not increasing, or maybe it is. We'll see what happens. And it finished. Now I have all of the combined text. My memory didn't even go too high because it was processing piece by piece. Finally, we have 11 billion bytes. Wait. Then how many characters, I wonder? I guess if it's... I don't know if it's bytes. It should be characters, not bytes. So double the bytes. So write code that will download this new file to my PC. I will just run it. And now it's gonna be downloading, because I click here download and it's not downloading. So I guess I'm gonna, in my experience, this downloading works better when I code it. I hope my RAM won't be like blowing up. It should start downloading. But I pressed cancel, so it deleted this. I guess let's accept and run. I'm not sure what's happening. Maybe it needs a lot of time. I don't know if I need any of this, but let me just install this to make sure. I think I will need. So then after that we do this one, but this will require a reset. Or not. Maybe not, because we are on GPU, maybe it's different. And then after that, large scale BP tokenizer for 12 billion characters. Why is it just 12 billion? It should be... What's this? Why is there this? Okay. Are there any other issues? No. So let's see how long this takes. Minimum token frequency. This is too low. No. 65. We need 120k. So if I go 65k. So walkup size options. I will find this and I will set here 1. That's the 120K. So now, fail to download. What? What's happening? Why is it downloading number 25? What is it doing? What? So I told it to do it one by one. You can't do it like that. So let me just send this message. I don't know what it's doing now. Look, it has 3000 files. There is just like 36 files. So I think I'll just start from scratch because maybe the prompt was too difficult. And this guy is not so fast actually. It's been like half an hour or more, and it's only at 3 billion, so it has 4 times this. Turns out Hugging Face has these tokenizers that you can train Byte-Pair Encoding Tokenizer, and you don't need to write it from scratch like I used Claude to do. So I'll try this one out, because this one I have to stop it again, but my other one is actually going well. So I'll just let this one go. I don't even know what I'm gonna do in the end, if it's gonna work out, and then I will do this in parallel. So it looks good here. It looks like, as I said, just 3, and then run some iterations, and then it looks like it's not the best. What is this? I guess this one, tokenizer. You see, this is not good. I'll just paste this output because this was written by what is it, Gemini. So I'll check the code as well. Okay, so it wrote some explanation. Let me just paste the code and run it again. Okay, step 3 immediately is good. Let me check this Web3 token, web text tokenizer. Okay. And then below we have entire vocabulary. Oh, the vocabulary, 90,000 rows. How many tokens? 31,000 tokens. How did it go so fast? Internationally, Bangalore. This is crazy. I wonder if it will tokenize properly. But I don't like that it's not separating white space in the beginning. I think if we check, it also got so many Chinese characters. Oh, these are Chinese. I actually know some Chinese, but okay. Tuan, Bu Xia Shang, San, Fang Yi. I don't know. This is Le. This is Yi, I think. Or no, maybe. This is Ta. Xi. Le. Shi. R. Shou. Maybe. Yeah. So in the second improved version, actually for now I'm gonna only keep English letters, and these are merges. Okay, I guess the data has so much Chinese text as well. So let me ask Claude. It's better at coding, so maybe, but you know, the website is not working all the time. Claude recommended a fix. So let me replace all of this. I guess everything is kept. Oh my god, what is that? I told it not to use tokenizers library and to write its own BP. And finally, after a few hours, it completely failed. You see, it just paired characters. It didn't even, I don't know what it even did, but it just made some pairs, 2 character pairs, and that's it. I guess we need to go from the beginning again. Oof. But this time I need to think about it and make it good step by step. I'm inspecting. So I downloaded one of the Parquet files. If I just show you this text, it's just this text of this blog or document, whatever it is. So I just want to filter files out of 765 only that has 26 English letters, and other ones discard. But this will filter a lot of it. You see, discarded 70,000 and saved just almost 10,000. So I think we can't do it like this. But that's because they also have these like white space, dot and stuff. So it's good that I saw what these are. Now I see the mistake I made. But ASCII do contain dot and comma and all this good stuff. So I don't know. Okay. So I told it it's filtering out too many. How do I reduce the amount filtered out but only keep English language? So the trick is a document written primarily in English will have a very low ratio, under 5% of non-ASCII characters. And Chinese, Japanese, Russian will have high, over 50% of non-ASCII. So that's the trick, nice trick. I'm telling you, this stuff is AGI. It knows, it's AGI. Let me run this. I did not install this package. It told me to install this. So now it has 81,000 documents kept. That is a lot of documents kept. Okay. I told it now to do it for 3 documents, not just 1. So if I go here, let's say downloading files, it's doing all at once, which is, I don't like it. It downloaded all 3. So I guess this should be very slow, 3 times slower. So it would take like 1.5 minutes. So we got some errors, and this is prime time. Oh, because of the out of memory maybe. Okay, so this is prime time to actually use Claude. I told it do one by one as you don't have enough memory, and maybe you can randomly check characters instead of checking all of them, and check enough characters. But Claude's website doesn't work as usual. Look at this, bro. Oh my god. I don't understand why. Why do they do this? This is way too slow. It takes a few minutes for one file. So we have improved version. I just told Gemini, and it's showing the progress as well. I told it to show progress. All file processed, no documents were processed. Actually, in data frame quality signals and then this row, you can see how much there is English. So if you say text 43, I discovered this is Chinese, If you look at here 43, it says 0.001 English. So now it finally works. Now I can filter out all of the non-English documents. I will train it on 1 billion characters, the Byte-Pair Encoder. I'm getting recommended by Claude and Gemini and ChatGPT 1 billion characters for 120,000 token size, vocab size. My whole pre-training dataset, by the way, is maybe 10 to 12 billion, so it's not even that much higher, more. So it will actually be significantly faster. And it's M4, not even M1, it's M4 Pro that I have. So it says here, my MacBook would take 4 to 6 hours, and Google Colab would take 20 to 30 plus hours, which is, I don't think it would take this much. Maybe 1 billion characters, that's why. Okay, it's giving me already the code, and I think I'll just take. Okay, it says M4 can handle more. Okay, I'll leave it at 4 then. So that will be 1,200,000,000 characters. Okay, I guess I'll just copy paste and run this. I kicked it off. I think it's still downloading. It says here 150 gigabytes per second memory bandwidth. I don't know exactly what that means. Actually, I just downloaded like 1 or 2 of them first, and my internet seems to be very slow. I wanna test what happens if I just download 1 and try to do this on a small set of characters. Good thing here is that I can just download it once and then it's gonna be saved in my memory, unlike the Google Colab one. Looks like the test merging is working. I just don't know what kind of characters it's merging, but I think it's good. Okay, it's the next morning, so it says here 120k vocabulary ready for this training. It will take 77 hours. So how did that estimate this? So 744 merges. First, I will just download files. So I have this new download file spy, and I will download. See, it's downloading here, so my internet is a bit slow. But I just told Claude, and Claude is best coder for sure, better than Gemini and ChatGPT and everybody. Especially, I mean, in these things that I'm doing. Okay. So I will just download it there. It will take maybe 20 minutes or more. It looks like it downloaded all 3 files here. So it says 6 to 8 hours, but this is just estimate. So then I have this new script, pre-tokenize. So instead of running BP immediately, this will filter for English text, and it will run this regex. So regex is a lot faster, and we already know which kind of tokens we will get in our vocabulary. So we can just shortcut it by running the regex for a bunch of tokens that we already know we will have. So I had some bug, but Claude fixed it. Claude is the best. Okay, and here we are processing first file, pre-tokenizing, so it's 100% done. 79,000 documents, and it says here 5,000 documents per second. That is so fast. This MacBook is crazy. It's getting hot heated. So this is number of English documents. It's also processing English documents, and this is total number of characters, almost 300 million. So total tokens 61 million. That's crazy. It's already condensed it a lot actually. So now it will be a lot faster. I think this will be like a huge speed up. Okay, second one. So it condensed to 61 million. 260, it's similar but a bit different. And 58 million. So writing JSON-L here, I wonder, I have too many files here. I wonder which one it will write to. Okay. So it has 1.4 gigabytes. Let me open anyways. Here we have so many tokens. Some of them are not even displayable, it seems. And we have a bunch of same tokens. But yeah, so many words with the regex. And finally, Claude wrote this train bp.py. I'm using Claude here on LLM Arena, direct chat. It's so good, and the Claude website doesn't even work, and this is for free here. So let me run this. So this should run for a long time. I'm gonna generate this many tokens. So it's train Byte-Pair Encoder. Let's go. Okay. Okay, it's fast. I mean, it's fast, but there is so many documents. Okay, oh, it's just loading. Oh, it's not merging, it's just loading. Oh my god, okay. Token frequency analysis. It has 180 million tokens. I actually think that this loaded everything. I don't know what it did. Let's check this. What is this? Token frequency, unique tokens, almost 2 million. 180 million tokens, frequency distribution. Most frequent token is 6 million times. Maybe the double new line token or something. Medium frequency, least frequent 1. Occurrence, we will not have this token like alone. Top 20 most frequent tokens. It's comma, the, dot, and new line here. Okay. And then some of these other tokens. So converting tokens to Byte-Pair Encoder format. And now it's processing these chunks. Why is it not moving? I don't know. It's starting merges here, starting BP merges. Seems to be very slow, so there is 0 right now. I don't know what's happening, but we'll see. This is way too slow. You see, it's taking like 12, 20 minutes for 5 merges, and there is 100,000. So I told that to Claude, and it told me to stop it and then to change. And we will use different vocabulary size for testing. So let me Control C to stop. Okay, then I will replace this code, and also I will use this test setup. So it's 32,000 now. Show me the console. Okay, let me comment this out. Do it like this. Let me actually try with just 4,000 tokens. And now let me run this. But the problem is this pre-tokenized stuff already has 53,000 tokens, and a bunch of them are just ones. So I'm going to only save tokens that appear more than 500 times in this data. So in the whole data, they will appear more than 1,500, 2,000 times probably on average. So that's what we need. So we need like a token to appear more than 1,500 times in data in order to learn it properly. So I will just discard everything less than 500 in this chunk of data, because it's a small chunk of data, not all data. So less than 500 here. Okay. So I'll just copy what Claude did here. So we filter for tokens that only appear more than 500 times, and it's covering 99.91% of data, which means the other data is not covered by these tokens. I guess it will be unknown data, or we will just filter it out or something. Now it's doing some stuff. So now it will again load the base frequent vocabulary. Each token has more than 500 times appearance, and then re-tokenize the data, and then find adjacent token pairs that are very frequently adjacent, and then merge them until we get this vocabulary or pairs become too infrequent. So I don't know what's happening now. I guess I'll just wait. So it's finished in like 5 minutes, even though Claude says it would take like 1 hour or 2 hours. And I asked, and it says here, no, it's actually nothing wrong here. Your MPro just crashed the task. I hope, because I don't know what happened. It finished like so quickly. So efficient algorithm used heaps instead of scanning everything repeatedly. Smart approach started with 50k plus quality base tokens, not individual characters, and then 25k merges per second is blazingly fast. Optimized code, no wasted compute. Okay. So we got our target. Looks like we have a lot of unknown tokens, which is crazy. Why do we have so many unknown? Look, everything is unknown. Ah, this is not good, not good, not good. But I discovered the issue. So not every token appears more than 500 times, which it should. So it just, I guess, merged whatever it could quickly. So let's create some code that will actually have every token at least 500 times in the text. Okay, I feel like I learned a lot about tokenization, and I learned that this is way harder than I thought. So maybe I just, you see, I have a problem here as well. Now it's merging unknown tokens. There is too many of them, and it's very slow and stuff. And this needs complex algorithms and a lot of stuff. So I guess we'll just use GPT-4 tokenizer or some similar tokenizer, and that's it. Okay, I told it, let's just load couple tokenizers from Hugging Face and tokenize some of my text and write some statistics that will help me choose the best tokenizer for my text. So I will, I don't know, it will write some statistic. I will see what statistic those are and how I can choose. I will try Quen, GPT, maybe DeepSeek, Llama, and other tokenizers. Besides Quen and GPT, I will use Llama, DeepSeek, and Minimax tokenizers, and then I will tokenize 100 million characters, and I want to just find which tokenizer has so I want to check for each tokenizer how many infrequent tokens it has. So tokens that appear like just once or 0 times, and this is not good. So I want to choose tokenizer that has least of these infrequent tokens, so my training data can so it can learn from my training data. So it loaded all 4 except Llama Scout. I don't know what this company is doing, bro. It loaded the other 4 tokenizers, GPT, Quen, DeepSeek, and Minimax, and it looks like it immediately very quickly tokenized all the text. Okay, so usage, oof. we have a lot of infrequent tokens. So it seems like a lot of vocabulary is just unused. I guess DeepSeek has a lot of Chinese characters. Minimax as well. GPT-4o. Okay, so I guess I'll just use GPT-4o because I feel like there is a lot of used characters, maybe 100,000 used tokens here. Yeah, use 100,000 tokens. I think that's good. Even Minimax, even more. And then I will just remove all of the other unused tokens maybe. Low frequency only once, 15,000, less than 530, less than 1040. Okay, so these are good. So this is for GPT for low frequency. And then these are percentages. Quen is also good. DeepSeek is even better maybe. I don't know what this means, bro. I feel like it's telling me that DeepSeek is better, is the best here due to this analysis. But I'm not really sure how to analyze. Seems kind of complex to analyze. I guess I'll just pick one. Either GPT or DeepSeek, I'm not sure. It looks like we will just pick DeepSeek R1 tokenizer. And that's it. Now I told it to just use DeepSeek R1, tokenize these 3 files, and then write analysis and speed like unused frequency, unused tokens frequency, etc. So we tokenized all 3 files. Frequency 1, 7,000 tokens. Frequency more than 5, more than 10. This seems all good actually. So it feels like we got 27,000 unused tokens and we have used 100,000 out of 128,000. Actually, this is quite good. I don't know why it's so high usage. I guess maybe we even have Chinese characters within our texts. For example, I wonder if all of these are Chinese characters or most of them, and if there is any of them in the used vocabulary, because I filtered for English only. Look at the tokens. So comma, most frequent token, and these are so this is the frequency. It's actually well arranged by frequency. 3,005. It's all good, it's all good. But you see how many we got Chinese and all of these other Cyrillic and other languages. I think then if this is the case, I think we will just use this tokenizer, because I did not know this is Tantan Wakandao. I saw it's so easy. Nanhaize, and then what is this? Henbu, and then Qilai, Shoufa maybe. Anyways. There is so many, so I guess all of the tokens will be used then. If I go check unused tokens, what is this? Okay, we just got a bunch of Chinese characters. Huichu, return. Okay. I have all Chinese characters. Maybe I can remove these unused tokens. Maybe I can remove them. I think I will just use DeepSeek Tokenizer as is, because creating it smaller, making it smaller and stuff, it will just be complex, and I don't know if I will even be able to do it. So I'll just use DeepSeek Tokenizer as is. And maybe later we will make a better or smaller or a new tokenizer and stuff.